So lesson 3, we talked a little bit about, we went to the lab yesterday and we did this, right? We got some results from this, hopefully. So what I need you guys to do is basically fill in some numbers here for me, and you're going to come up here and fill some in for me as well. Remember, right here, that's your weight of the empty test tube. Okay, that should go there. That's the very first recording that you took, was the empty test tube. Okay. The second one here should be the weight of the malachite, the green stuff only. Okay. So in some cases, I gave you guys 0.4, 0.6, 0.8, 1. Somebody got 1.4, 1.6, 2 kind of thing. So that's what I want to see there. Okay. Yes. Okay. And if it wasn't exactly 0.4, if you did 0.39 or 0.41, then that's the number I want to see there still. So 0.39, 0.41, whatever, that's the number that needs to go there. Okay? Or if you had the 2.1, then I want to see 2 or 1.99 or 2.01 or whatever it goes there. The very last measurement you took was the weight of the test tube and the black stuff. Okay? Yes? So the weight of the test tube and the black stuff was the very last weight you took. And I want you to take that number and subtract just the test tube, right? And that should be the number that goes here. Okay? So you're going to take the weight, the very last measurement you took was the test tube with the black stuff in it. And what I need you to do is subtract the test tube from that, because I just want the weight of the black stuff, and I want that to go here. Okay? So just the black stuff here, just the green stuff here, and this is your empty one here, of course. When you have that, I'm going to get you to come up here and find it on this chart here that you guys also have as well. And I want you guys to record these numbers, not only yours, but other groups as well. So whichever one matches up. For example, if you were 0.40, if that was you, I want you to come up here and I want you to write down what was the actual weight that you used here. That would be the green stuff. Okay? So if it wasn't 0.40, once again, I want the 0.39 or the 0.41 there, or whatever it was. And I want the weight of the black stuff in this column here. Yes? Okay? So I want you guys to do that now. When you got that done, I want you up here and I want these numbers recorded. Go now. Let me record this for the people that are in Mexico. Eh? It's a rough life, eh? Yeah. Sitting on the beach looking at their iPad. Curse them. Hey, drinking, eating all buffet, all you can eat buffet. Hey, people. I don't know, people. How come you're not in Mexico, speaking of? Yeah, you. Hey? All right. You should be. Why not? All right, here we go. So we got these numbers here that you guys, like I said, recorded from yesterday. We now need to change this, though, because there is no, I'll tell you right now, there is not a relationship between the mass that you burn and the mass that you get. So what I need you to do now, if you look here, it's I can kind of see a relationship here roughly. But it's not very evident with the masses. What we need to do is change these to moles. So we're going to take all the numbers here. So for example, group whatever 0.4, you're going to have to change that into moles of malachite. This is the green stuff, and this is still the black stuff here. We need to change these into moles of malachite and moles of copper 2 oxide. To do that, you need to find the molar mass of malachite and the molar mass of copper 2 oxide. So you're going to do that now. This is a good test for you to see if you can come up with the right molar mass for malachite. Okay? Go. .221.13 grams per mole. Winna, chicken dinner. Yeah? I don't know what that means, but molar mass of copper 2 oxide, that's an easier one. 79.55 for the double win. Double word score, whatever. Okay? Now, your next job, like I said, is you need to convert all those grams. So these ones here, in this column here, you're going to convert all those grams you see there, not all of them, but the ones we've done, to moles, and you're going to write them in on the first column on the next sheet. So all those converted to moles are going to go here, right, in this part here. 1, 2, 3, 4, 5, 6, somewhere up to here-ish or so. 1, 2, 3, 4, 5, 6, there, I guess. Okay, so you're going to record those there. You're going to record the corresponding moles of copper-2 oxide beside it. So you're going to go back to here, and all these numbers here need to get changed to moles, and you're going to write them down here in the first 7 blanks here, right there. Okay, good, go. So, okay, good. So this is what you would get when you change all these to moles. Okay. Now, is there a relationship between moles here? There should be. What do you notice as you look across here, roughly? Look across, look across, look across, look across. Is there a relationship that you see between moles of malachite, the green stuff, and moles of copper-2 oxide? What do you think? Yes? Yeah. There is, yeah. Is there a specific ratio that we're kind of looking at for here? Yep. It's about twice the amount. Okay? Yes? We could actually go through and figure out who really messed up. Eh? But it's about twice the amount. Actually, I think you guys read this. They're all pretty close. Okay? And if you want, you could actually divide the two numbers and see which one is actually the farthest off, and then we can make fun of you later. Okay? But we don't need to worry about that right now. But most of them are about 2. Yeah? Pretty close? Yeah? Or you could take this number here and multiply by 2. Why can we do that? Why did we have that? Well, remember, last day we looked at this right here, right? Copper-2 carbonate, copper-2 hydroxide, that's malachite. And when we balanced the chemical equation here, we put a 2 there, right? And I said that's balanced. Look, for every one of these that you decompose, for every one malachite, you can think about a molecule. If you could pick out one molecule, you would get 2 copper-2 oxides and one water gas and 1 carbon dioxide gas. But we got rid of the water and the carbon dioxide yesterday. You could actually see the steam as it was leaving, right? Some of it didn't quite get out quite right away because it was not hot enough up there. But there's a direct relationship between 1 to 2. This is the green stuff that you weighed out, and this is the black stuff at the end that you ended up with, and we don't have any of the water or the carbon dioxide because we burned it off. Or it left anyway. I shouldn't say we maybe didn't burn it off, but it left, right? So it's a 1 to 2 relationship, right? So if this is true, if this is a 1 to 2, where did we get this equation from? I told you yesterday that's the equation, right? This is the equation. We balanced it yesterday. It's a 1 to 2 relationship. Does that actually hold true for our experiment yesterday? Is this true, or am I making stuff up? Well, is it a 1 to 2? I don't know. It's pretty darn close. Is it not? I mean, it is an experiment, so you got to take it with a little grain of salt, of course. Everything's going to be a little bit off, and there's some rounding issues, sure. But if this is 0.0018, shouldn't this be 0.0036? So pretty close, right? Think about it. This is the tenths, hundredths, thousandths, 10,000ths place. So you're off by 1/10,000th of a mole. Okay? Group 1 screwed up, obviously. Hey? Well, that's horrendous. No, I'm just kidding. Hey? Look, that's good, right? 1/10,000th of a mole you're off by, right? So it's probably, hey, I give you a little bit of leeway there. That's probably okay, all right? It's pretty darn good, actually. This was 28 here. This should have been 56. So group 2, hey, well, it's not that bad, actually, right? Group 2, I mean, they're off by, once again, probably 1/10,000th of a mole. Close to 2 almost, okay, if you want to get picky. 44, right? Well, 44.8, so if you doubled that, it's what, 89.6, and somebody got 89.2, well, 89.2 there. So you're off by 400 thousandths of a mole. Okay, that's pretty good. All right. That's 100 thousandths, right? 54 here, you should get about 108 there. Or somebody, well, 54.7, so let's go with, well, whatever. You're pretty, the point is you're pretty close, all right? So I don't think we need to keep going. You get the idea, right? I mean, we're off by thousandths of a mole, and it's an experiment. So let's not, like, overanalyze this, right? Do you agree that it's a 1 to 2 factor for the most part? Okay. You know, 71, we should have got 142 maybe there, but that's not much, okay? 63, yeah, looks good, you know. So it's true, okay? I would say, I hope we can agree with that, you know, when we're off by 1/10,000th of a mole or 400 thousandths of a mole, okay? I would say probably this relationship here is probably pretty safe. This turns out to be a 1 to 2 relationship, yeah? Yeah? And we proved it yesterday. So what the purpose of yesterday is just to get you a little practice with the Bunsen burner and go through a little bit that with you, which you didn't get a lot of practice of, I know, but just to show you that, in fact, hey, we're not making stuff up here, right? If you burn 1 mole of malachite, by the way, 1 mole of malachite weighs 222 grams, yeah? 0.13. So we're not going to burn a mole. That's 222 grams. That'd be the entire bottle, okay? You would get 2 moles of copper 2 oxide, right? Sorry, and I said burn. I should have said decomposed, right? Because that's what we did yesterday, decomposition. We didn't burn it. We decomposed it. But if you took 1 mole of malachite, you get 2 moles of copper 2 oxide, right? And you just proved it right here, guys. All this, you know, times 2, times 2, times 2, times 2, times 2, times 2, right? That proves it. For every 1 that you guys decomposed, you got 2 yesterday. We did 7 different results, 7 different experiments, and it works out very closely, okay? So we're not making stuff up here when we say, hey, use the balanced chemical equation, and we should be able to figure out how much we should get. Yeah, we should be able to do that, okay? And that's what we're going to look at today. So let's do that.